Alright guys, welcome back to Final Exam Guy. Today we're going to be looking at a few problems, solve problems in Rolle's Theorem. So before we start, don't forget to subscribe to my channel and support me. Also, you want to share these videos with people you know so that they can learn as well. And drop a like if you learned something today. So what is Rolle's Theorem? Rolle's Theorem says that if our function f is a continuous over the interval a to b, and differentiable in the open interval a to b, and if f of a equals f of b equals 0, then there must be at least one number c in that interval, such that the derivative with c plugged into it will give you 0 back. So let's see here. Explaining what this means would be best to show you in an example right here. So is our function here, number one, is it continuous over an interval? Yes, it is. If I plug in anything in this interval, the function will give me back something. It will not give me does not exist or whatever. It works. It's differentiable easily. We can see that here. So if I plug in, this is my a, this is my b. If I plug them into my function, I should get back 0 for Rolle's theorem to apply. So f of negative 1 is equal to 1 plus 2 minus 3 is equal to 0, and f of 3 is equal to 9 minus 6 minus 3 equals 0. So Rolle's theorem does apply. So that means there must be some c in between here, that if I take the derivative of my function and I plug in c, I'll get back 0. So we gotta find that c value. So to do that, we take the derivative of our function. So we get f of prime of x is equal to 2x minus 2. And if we set 2x minus 2 equal to 0, we can find our value for c. So solving this, we get x is equal to 1, which is equal to c, because and you see that the c value is between our interval of negative 1 to 3. It lies between. And if I plug f prime of 1 into my function, I should get back 0. So let's test that out. It's equal. So plugging it into 2x minus 2, so we get 2 times 1 minus 2 equals 0. So Rolle's theorem applies to this function, and we showed that there was a value c, that f prime of c equals 0. So let's move on to the next question. Alright, so the next question, we have f of x is equal to x cubed minus x on the interval 0 to 1. Obviously it's continuous and differentiable, so let's find our f of 0 and f of 1. F of 0 gives you 0 minus 0, 0. F of 1 gives 1 minus 1, 0, so Rolle's applies. So there must be some value of c between a and b that will give you, plugging in that c into the derivative will give you 0. Some c that this happens. So what I would do is take the derivative of our function. So derivative is 3x squared minus 1. If I set it equal to 0 and I solve for x, I got x squared is equal to 1 over 3. X is equal to root 1 by 3. Okay, and now we must not forget our plus and minus here from square rooting. So only our positive plus root 1 over 3 lies, it's all rooted by the way, lies in the interval 0 to 1. And if I were to plug in f prime of root 1 over 3, I'll get back 0. Alright, so the next one is asking us for this function here, negative 2 over 3 to 2 over 3 interval. Is it continuous? Yes, it is. It looks like all the other ones we've been doing. Is it differentiable? Yes, it is. So let's find our f of negative 2 by 3. So if we plug in negative 2 by 3 here, we'll see that it is 0. F of 2 by 3 as well as 0. You can try it yourself if you want. So that means there must exist some c on this interval, that makes f prime of c equal to 0. So if I take f prime of this function, we get 27x squared minus 4. We set it equal to 0. 27x squared is equal to 4. X squared is equal to 4 over 27. X is equal to root 4 over 27. So if I go ahead and plug, so this is c, f prime of root, you do get 0, which is the Rolle's theorem. Alright, so question 4 asks us for x squared minus x minus 6 over x minus 1 on the interval negative 2 to 3. So Rolle's theorem, we're going to do f of negative 2, f of 3 equals. No, guys, no. Wrong. This is the problem. If x equals 1, we get negative 6 over 0. Discontinuous, guys. Rolle's theorem does not apply. Does not apply for discontinuous functions, because the function has to be continuous in the interval, and 1 happens to lie in the interval, so Rolle's theorem does not apply. Just because I'm really cool, I want to show you guys a graphical explanation of Rolle's theorem before we move forward, for your own benefit. So, so we have a graph. It's not the best color, not the best shape. We have point A at the interval that we are usually given in the Rolle's theorem problem, A to B. We know that f of A must equal 0 equals f of b for Rolle's theorem to apply. So that would bring us to this point and this point. So, and we have a curve here, so that must be continuous and differentiable, right? So, there must be some argument c between a and b such that if we plug it into the derivative, we get 0. This just means that there must be some point c on this curve where f prime of c, if I plug in c, I'll get 0. That means I'll get a horizontal tangent line. And in this case, it's right in the middle, right? So that's all it means, guys. There has to be a point where the slope of that point is horizontal. Alright, so the last question. It's important to note that f of a and must equal to f of b. They could be any number. It could be anything other than 0 as well, as long as they're the same. So you don't have to just stick with 0 over here. So we'll see that in this example here. So we got f of x equals sine x plus 2. If I go and plug in f of 0, so we'll just get 2 f of 2 pi. We get 2 as well, so Rolle's applies. So there must be some value c such that f prime of c equals 0. So what's f prime of our function? Just cosine x. So if we go ahead and f prime of c, set it equal to 0, equals cos of c equals to 0. And we got a cosine here, so we know that there must be, on the circle, there must be 2 solutions. So c1 is equal to 0. C1 is this pi over 2 is one solution, and C2 is 3 pi by 2. We check if both of these are in our interval, which they are. So there exists 2 points where there's a horizontal derivative, horizontal slope. So this would look like this if I were to draw this this function. it would look something like this. Right? It's cosine, right? So there's 2 points here where there's horizontals. Here, slope is 0. 2 points, and you guessed it, these points are 3 pi by 2 and pi by 2. And our intervals were a to b. 2 pi here. So that's all about Rolle's theorem, guys. I hope you learned something here today. If you did so, don't forget to subscribe to my channel and share the video with people you know so they can learn about Rolle's theorem as well. I'll see you guys in the next solved problems video.